What up, calculus students? We are getting ready for the Unit 8 tests. 6 problems. Making sure we understand what we're doing. Starting with the first 2 questions which were some of your worst performed questions throughout this unit. The quiz questions off of this. We keep in mind the fundamental theorem of calculus at all times that equates accumulations with kind of going backwards. So like f prime, f double prime. If you accumulate f prime, you get a change in f. If I'm going to accumulate r, no matter what r is, I would get a change in its previous guy. Well, we'll call the previous guy super r, big R of x minus big R of -3. And if I was able to find the equations of big R, I could potentially use it. Maybe they're not used, but there it is. Now what helps me is if I take the derivative of h and I have h prime, I realize that maybe this derivative doesn't make sense to me, but the derivative of this does. The derivative of big R goes back to regular R, but with x's instead of t's. And then the derivative of r of 3, this is like a constant, it's like a number, it's 0. And then the second derivative of h will be the first derivative of r, again, minus 0. Cool, so this is all options for finding values. But if I start at h of -5, I'm going to understand that big R of -5 minus big R of -3 is not something I find because I have the graph of R. Well, it turns out r is the same as h prime. We could write this as h prime. But the way to actually complete this is understanding that sometimes you can find accumulations geometrically. Since these are all straight lines, I can actually look at the accumulation of r from -3 to -5. Now, before I jump into finding this answer, I probably should find these accumulations and make sure I understand. It's the shaded area because we're adding up all the values from the x-axis down. Don't create different regions, don't create different shapes. Just make sure you go from left to right and either up or down from the x-axis. This is a triangle base 2, height 2, so this is going to be a 2 here, and I'm going to say it's a positive 2 if I'm looking from left to right. This is going to be a 1, 2, 3 by 1, 2, 3, 4. So that's going to be a 12 divided by 2, 6. This is a 2 by 4, which is going to be a 4. And this is a 2 by -4, which is -4. Great. If I'm going backwards, it's the opposite of if I go forward. So if I go from -5 to -3, I will say it's positive 2, but I'll take the opposite and have my answer of -2. If I want to go from -3 to 2, I'm replacing x with 2. I purposely use like different letters just to really make sure you understand what you're doing. I'm not going to use super r. Instead, I'm just going to accumulate from -3 to 2, and I get 10. I've already found that h prime is equal to r. Since h prime just equals r of x minus 0, h prime of 3 equals r of 3. R of 3 is the point here at 3, which is -2. That means h double prime will equal r prime. R prime of 1 will be the slope. I go down 1, 2, 3, 4 over 1, 2, so it's -2 as well. For 2 different reasons. This is a point, that's a slope. All right, what if I change it up and I have d? Well, I can say d of x is also equal to big R of x squared minus big R of -5. Cool. Let's just keep that available. Oh, shoot. It's supposed to say d. D. Okay, what's d of 2? Well, I actually don't have big R, so I'm going to go back to just plugging 2 in here and just say it's the accumulation from -5 to 4 of R. Accumulating from -5 to 4 would accumulate everything. So this is good that I changed it to -5. Pay attention to that. So I have an 8, 9, 10, 11, 12 minus 4 goes back to 8. But what about d prime? Now don't plug in 2 yet until we understand d's derivative. If you take d's derivative, you have to use the chain rule. The derivative of r of x squared is an O and an I. The O is r, whose derivative is regular r. The x squared's derivative is 2x. It's regular r of x squared times 2x minus 0. That's the derivative of big R of negative 5. That means d prime of 2 will be R of 4 times 4. R is given. R of 4 is negative 4. Negative 4 times 4 is negative 16. What if I gave you this? Well, this is where, knowing that J has an alternate form of regular f of x. Oh, jeez, it's supposed to be R. I gotta change some stuff up. My bad. I made this on over the weekend. So I have to print out some different copies. Regular R of x squared minus regular R of negative 3. This is something I can find. J of negative 2 would be regular R of 4 minus regular R of negative 3. That's something I can find. Regular R of 4 is negative 4. Regular R of negative 3 is 0. So I'm decreasing 4 total. That is my displacement of R. J prime of negative 2, I'm not going to find yet until I understand the value of J's derivative at x. I'm going to take the derivative of this and get the derivative of regular R would be R prime of x squared times 2x minus 0. So J prime of negative 2 would be R prime of 4 times negative 4. R prime of 4, I can't really find. I can kind of assume it's negative 2, but it's an endpoint, so let's go ahead and just assume we're going on forever and ever and ever to get positive 8. Again, make sure you understand where these values come from and not memorize. Find the minimum value of h. All right, well, I'd love to understand h's derivative and how that's changing. I know h's derivative is r, so this is the graph of the derivative. So I want to know the signs, not increasing, decreasing, rather positives or negatives. It's very important to include all of the zeros because we got to be very specific for our justifications to get full credit. So we got positive, positive until 2, and then negative after that. That means h is increasing, flattening out, increasing, then decreasing. Again, I should know if my function's increasing, increasing, then decreasing, that h of negative 5 or h of 4 are possible mins because h prime, which equals r, is greater than 0 from negative 5 to negative 3. These are x's actually. From negative 3 to 2. And then h prime, which equals r, is less than 0 from negative 2 to, 2 to 4. Got to compare the two values. H of negative 5, I found earlier, so I don't have to write it down again. It's negative 2. H of 4, did I find H of 4 earlier? I did not, so I got to write down, it's the accumulation from negative 3 to 4 of R. From negative 3 to 4 will be this 6, this 4, this negative 4, so that's 6. So I find that h of negative 5 is our min value. It's our winner. Okay, cool. Points of inflection for h is when h concavity changes. H's concavity changes when h prime changes direction, or when h double prime changes sign. H prime equals r. I'm going to look at when r has maxes or mins, as that's when r will change directions. I'm not sure if they accept changes directions for justification. Our answers are x equals -3 and x equals 0, because that's when h prime, which equals r, changes directions. So x equals -3 and x equals 0, because h prime, which equals r, changes direction. Or you could say h prime, which equals r, has a max or min. That is a quick way of saying h prime, which equals r, changes directions. Cool, that's it. Changing it up. Cool. N's and M's. Making sure you guys are ready to adjust and adapt. N of x could equal super M of x minus super M of 0. N prime equals regular M of x minus 0. And double prime equals M prime. N of 3. We could either find this or find that. I don't have super M. This is the graph of M. I realize M is the derivative of N. So I'm not going to do that. Instead, I just need to accumulate from 0 to 3. So this is tricky. This is at 1.5, right? This is down 1, 2, 3 over 1. This is down 6 over 3. So I go down 2 over 1. Down 2 over 1. This gives me 1.5. Okay, so I have a 3 halves times 3 halves. So it's 9/4 is this area. This is -9/4. This is good. This is good. So this is at least 0. At least that's easy to do because I'm accumulating positive and negative. Let's keep going. Let's make sure we have all of our regions. We have this quarter circle, and this is a quarter circle. Now, it will be told to you that these are quarter circles. If they are not told to you that they're quarter circles, don't assume they are. Just because you're curved doesn't mean you're circular. This is a quarter of a pi r squared with an r of 1. This is a quarter of a pi r squared, which is an r of 3. So this is 9 pi over 4. These are fun problems. 3.5 times a half is 3/4 times 3 is 9/4. So n of -4 would be the accumulation from 0 to -4 of m, which I can do because I have 2 quarter circles. Quarter circles, just reminding myself for adjustments to the copies of this, what we got going on here. So adding them together would be 2 pi. Going backwards would be -2 pi. 8 pi over 4, 1 pi over 4. Okay, n prime equals m. I already figured that out. M of 1 is 1. It's the value. Down 2 over 1. And prime of 1 will equal m prime of 1. We found that slope was -2. It's the slope of m at 1, down 6 over 3. Okay, w prime. All right, well, I know w of x would equal super m of 2x minus super m of 0. If I took the derivative, I'd have to use an o and an I to have m of 2x times 2. The outside is the big M. The inside is the 2x. Big M goes back to regular M of parentheses. 2x goes to 2. The super M of 0 is a number. Its derivative is 0. So W of -2 equals M of -4 times 2. M of -4 is -1. -1 times 2 is -2. Cool. Well, I know L equals regular m of 2x minus regular m of 0, because accumulating a derivative changing the previous guy. L of -2 equals m of -4 minus m of 0. M of -4 is this value, -1. M of 0 is this value, 3. increase. It should be 4. It's -4. Oh, because I'm going from 0 to -4. 0 to -4, we can see we decrease 4. I'm going backwards. Cool, 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 cool. So that's fun. And then L prime will be the derivative of this, which will be m prime of 2x times 2 minus 0. L prime of -2 will be m prime of -4 times 2. M slope at -4 looks like it's 0. We're going to just say it looks like it's 0 times 2. It's probably not safe to say that. Probably you want to see that this is the bottom. Min location of n. Oh, shoot. All right, so I'm going to look at n prime. N prime equals m. That's the graph of n prime, which is m. We're going to look at its signs. It's negative until -3. It's positive until 1.5. And then it's negative. Okay, so I know that n decreases, then increases, then decreases. So -3 or the endpoint 3 are my potential mins. So that's nice. I don't have to check all the endpoints. Okay, so my possible mins are n of -3 or n of 3 are my possible mins as n prime, which equals m, is less than 0 from -4 to -3 and from 1.5 to 3. And prime, which equals m, is greater than 0 from -3 to 1.5. It's very, very important if you want to get full credit on justifications to write this down, or you just don't get credit. You have to really explain why these are our possible mins. This justifies why those are our possible mins, but they don't accept this as work. So it's up to you to do the work, show the work. Okay, did I find n of 3? Great, n of 3 is 0. No, I didn't find it. I found n of 3. N of 3 is 0. I didn't find n of -3. So I have to do the accumulation from 0 to -3 of m. That accumulation going backwards is -9 pi over 4 because I'm going opposite. This is our min value and location. N is concave up. N is concave up when n prime is going up or when n double prime is positive. M, which equals n prime, is increasing, is what we're looking for. We are increasing from -4 to 0. Cool. That's your answers. That's the justification. I feel like there was supposed to be an E there. I gotta go back and change this up anyways, so. Might as well do it now. Look at all this stuff I put together for you guys. It's a lot of stuff. Okay. What was this? This should be R prime. This should be D. That's good, that's good. Which consists of 2 quarter circles and 1 straight line. Okay, and that's an E. Save. All right. We got bacteria. A nutrient-rich solution is pumped into the culture, introducing new bacteria array modeled by this. Cool. During the same time, a chemical agent causes bacteria to be removed or destroyed at a array modeled by this. This is great. So we have bacteria being added and killed. F prime, F double prime. Bacteria per hour. Bacteria per hour. Accumulating this would be added. Accumulating L would be removed. I have a initial position of 1,000. This would be bacteria. If I want to know how the rate of change is changing, I look at E prime and L prime. If I want to look how the total is changing, I would look at E and L. Let's graph. Break out Desmos. Cool. Maybe just so I can remind myself that. The total number of bacteria in the culture increasing or decreasing at T equals 4. I'm going to compare the rate at which bacteria are being added and the rate at which they are being destroyed. You can subtract them to get a total velocity of your situation. Or you could compare them. You could say your velocity at 4 is E of 4 minus L of 4, which will be positive if this is bigger than that, and negative if that's bigger than that. It's up to you what you want to do. You don't really have to do anything. It's whatever makes sense to you. This is the rate. Oh, that's a problem. Man, I like assume these are going to make sense. All right, well, let's see how I'm going to change this. Is it 800? I feel like I graphed this. Look at that. That's crazy. That doesn't work out. I feel like I graphed this and maybe it got all screwed up. Dividing by the cosine is a problem. Dividing by the cosine squared might be a solution. Making sure this never hits 0. Maybe we don't want to go all the way up to it. That looks better. L should be positive too. But it should be decreasing. Yikes. I hope I never asked for the max. Oh man, I really assumed this is going to work out. Jeez. All right, this works. All right, cool. Change it up. T plus 0.1. Cool. All right, let's look at E4 of an L4. I swear I looked at this. E4 is less than L4. Okay. So E of 4 is. Okay, now you can go away, and I want to go back to this. E of 4 is 113 bacteria per hour. L of 4 is 173 bacteria per hour. So we are removing more than we are gaining. We are destroying more than we are adding. We could subtract to find the velocity of the situation. Negative 60. Point 840 bacteria per hour. So E of 4 is less than L of 4, and or decreasing E of 4 is less than L of 4, or V of 4, which equals E of 4 minus L of 4, is negative. How many total bacteria introduced to the culture from 0 to 10? Total added is just going to be accumulating E to get the total bacteria. Accumulate the rate of change, you get a change in a total, 1308.818. Was the absolute number of bacteria in the culture over the interval 0 to 10. I gotta make sure that's changed up. Cool. Well, I can look at E equaling L. It looks like it's at 0. Now it's here. This really tiny time. Or I can look at the velocity of my situation and look at when that hits 0. I probably prefer to do this. Let's go to a home. Right there. That's the only value. Everything else must be like, I honestly must kill all the bacteria very quickly. Okay, so I can see that my velocity, which is E minus L, or you can look at E being bigger than L, occurs from 0 to A. A is 0.49149. Cool. So that means my velocity is positive, then negative. You can look at E being bigger than L, then L being bigger than E From then on, that means my position's increasing or decreasing. I know that my P of A must be the max because V, which equals E minus L, and you could also talk about E being bigger than L being big. We can say this is positive from 0 to A, and then V, which equals E minus L, is negative from A to 10. I had 10,000 to start with. You can add separately or accumulate your velocity, whatever you want. So either adding E and then subtracting the amount that were killed, or accumulating your velocity to get 10,073. Cool. The cost of culture to maintain the culture is $5 per hour plus an additional 2 cents for each bacteria removed or destroyed by the chemical agent. All right. So $5 per hour plus 2 cents for all bacteria removed. I don't know why we don't want to evaluate it. What's the idea? So $5 per hour for $10. Something like that. We could say the cost after T hours, this might be more realistic, would be 5 times T plus 0.02 times the integral from 0 to T hours of L. I don't want to say, I probably want to say L like that. Like it needs to be different variables to be good. All right. Sorry about the errors, but we fixed it. Cool, no calculator. A lot of the rest of the questions I think are no calculator, so you're ready. We are monitoring the population of a beehive. For 0 to 4 weeks, the exact number of bees in the hive is measured by this H. Cool. From 4 to 10, he could no longer monitor the exact population. He developed a model for the rate of change of the bees population in hundreds of bees per week. Cool. If we considered these as an FF prime and F double prime, we realize that H is in the hundreds of bees, but R is the rate of change in bees per week. Hundreds of bees. Okay. Great. This is a good question. How many bees are in the hive at T equals 2? Well, H of 2. It's the total amount of hundreds of bees. So it's 1/4 sine of 2 pi plus e to the 2 over 20, which is the answer, e to the 1/10. That's not that many bees. But whatever. I don't want to look at it. I don't want to look at it. Let's just go with what. Jeez. Doesn't I don't like this. I think I made this up and then I'm like, oh, I'm seriously regretting this. I hope things are all positive. What we want are bees coming in and out, you know. Yeah, this is good. I do like this. It's only just like not that many bees. Oh, it's hundreds of bees. This is fine. E to the 1/10 hundreds of bees. We're good. Is the population of the hive increasing or decreasing? Is the population increasing or decreasing? We got to look at its derivative. Great. So we need to actually take the derivative of h. O and I will have negative positive pi over 4 cosine pi t. O's and I's. The signed and the 1/4 constant stick around. The pi t will have a pi. This will be 1/4 cosine. The derivative of sine is positive cosine, so that's why I got positive pi over 4 cosine pi t plus e to the parentheses t over 20 can be thought of as 1/20th t, so the derivative would be 1/20th times e to the t over 20. H prime of 2 equals 0 plus 1/20th e to the 1/10th, which is greater than 0. So since h prime of 2 is greater than 0, h is increasing. How quickly is it increasing? It's increasing this many hundreds of bees per week. What is the average amount of bees? I would love to accumulate h and then divide over the interval. How can I accumulate h? I don't think I'm eating lunch today. Probably full. I can use super h of 4 minus super h of 0. Divide this by 4. All right, so I need super h by taking the antiderivative. Okay, so I need to undo the derivative. I need a 1 over pi. I need cosine's derivative is negative sine, so I need a 1 over 4, negative 1 over 4 pi cosine pi t. E to the parentheses antiderivative is an e to the parentheses, but then I need to undo with a 20. Cool. So super h of 4 is going to be negative 1 over 4 pi, because the cosine of 4 pi is the same as the cosine of 0, which is 1, plus 20 e to the 1/5 minus cosine of 0 is 1, so I have another negative 1/4 plus 20. This divided by 4 is the average population in hundreds of bees. Remember, if you accumulate h, you'll get bees times weeks. So we're going to go backwards if I have super h, but then make sure you divide to go back to an average bees. C, write an expression involving an integral that gives the total amount of bees in the hives from 4 to 10. Well, here's the deal. I need to know that accumulating R gives me the change in the population from 4 to 10. What I also need to incorporate is a starting position. Since R is a rate of change, we also have to consider how much is in the hive at h of 4. So h of 4 is e to the 1/5. This e to the 1/5 needs to be added to this. Now, how do I accumulate that? Well, I need super R of 10 minus super R of 4. This will give me the total bees. When I accumulate R, I'm going to get the total bees displaced, but I also need h of 4, which was the amount of bees at that time. This is a good question. Okay, so let's find super R. I need the antiderivative of this. This is 4t plus 2 to the negative first, so I'm going to know that it's going to be Keep the constant antiderivative of the negative first power as a log. Keep the constant antiderivative of 1/2 power, add 1 to the power, multiply by the reciprocal. 2/3 times 1/6 is going to be 2/18, which is 1/9. Cool. This would be the total amount of B's. Now, what's interesting is you could have actually said, okay, R of 4 could be found, and R of 4 has to equal super R of 4 has to equal H of 4 for this thing to be continuous. So you could have actually found C as a situation. You could have plugged in 4 and then solved for that set equal to e to the 1/5, which is why, like, remember about C's, we could actually go backwards and find C. And if you did that, if you went backwards and found C, good on you. It'll be a little bit messy, which is why I'm going to just not do it. And I'm going to say I have e to the 1/5 plus 4 log 12 plus 1/9 10 to the 3/2 minus R of 0 would be 4 log 2. So, sorry, R of 4 would be 4 log 6 plus 1/9 4 to the 3/2. This would be the total amount in hundreds of B's. Okay, so I probably would say this is the total amount of B's at certain t time. Don't let the t's agree, so I'm saying my population at a time. And then I found it at 10. Is the rate of change in B's increasing or decreasing at t equals 9? Is this increasing or decreasing? I'm going to look at R prime to figure out if R is increasing or decreasing. So we got to find R prime. The derivative of R. All right, let's find R prime. -4 t plus 2 to the -2 plus 1/12 t to the -1/2. R prime of 9 equals -4 over 11 squared plus 1/12 times 1/3. I don't know if this is positive or negative. This would be hundreds of B's per week squared. I'm just going to check really quickly. The values that you're going to have on your test are going to be totally doable. I just kind of made these problems up over the weekend without checking them. Oh, it's barely negative. That's crazy. This is the rate. So the answer is decreasing. R is decreasing. Rate of change of B's is decreasing. This is too hard for you to figure out. -0.005 hundreds of B's per week squared. Cool. 2 more. Riemann sums. Great. I did this in earlier class. So we got a freight elevator going up and down. I'm giving you the velocities in feet per minute, so we know that. We know an initial position. Position at time 0 is 20. So velocity is a derivative. It's a feet per minute. Accumulating velocity would give you a change in your position. Cool. Use a left Riemann sum to approximate this. All right, so 0 to 12 of V is literally going to give you how position is changing. It'll be in feet, change in position. Left Riemann sum, I got 0 to 3, which is 3 by 10. I got a 3 to 5, which is a 2 by 25. I got 5 to 8, which is a 3 by negative 15. I got an 8 to 12, which is a 4 by negative 5. 30 plus 50 minus 45 minus 20. So 5, 10, 15. 15. This is the displacement of position. This is the displacement of feet. This is how my position changed approximately. Use a trapezoidal sum to estimate the height of the elevator. Well, to find your height of the elevator, you need to add your initial position to your displacement. So we're going to make sure we add the 20 to our displacement from 0 to 12 of V, which we are approximating. Okay, half of my base length times the sum of the heights. So this is half of 3 times 35 plus half of 2 times 10. Half of 3 times negative 20. Plus half of 4 times 5. Whatever that is, we will add that to 20. I don't want you to simplify for your response on no calculator. Keep it unsimplified and it's correct. This is going to mean distance traveled, total distance traveled by the elevator. Any negative velocity you'll use as a positive. So it's going to be the same as the previous one. Only instead of the negative 15, I'll have a positive 15. And in the negative 5, I'm going to have a positive 5. Okay. Approximate A of 4. We know that A of 4 can be approximated with the average rate of change of V from 3 to 5. 3 to 5. Which equals a decrease of 25, 35, 40 over 2. So you can either do y2 minus y1 over x2 minus x1, or you can just kind of go straight to the answer. This will be feet per minute squared, which is telling you your velocity is decreasing. Approximately 20 feet per minute at t equals 4. Must there be a time over the interval where the acceleration equals 5? The mean value theorem is how we use it. All you have to do is say the velocity is differentiable, which means it's smooth and differentiable. This says differentiable, which means it's smooth and it's continuous. And all you have to do is find an average rate of change of velocity to equal 5. And the mean value theorem says you're guaranteed to have. So the average rate of change of velocity over the interval 0 to 3 equals 5. Therefore, by the mean value theorem, V prime at some time, which equals A at that some time, must equal 5. Must there be a time when the acceleration is 0? Yeah, from 0 to 12. You could have also said that my velocity increases then decreases, which means the acceleration must be positive than negative, which means we have to have a 0. So there's like ways to get around that, but we're going to just say yes. You could say the average rate of change of v from 0 to 12 is 0. Therefore, v prime, which equals a, must equal 0 by the mean value theorem. Or from 0 to 5, velocity must increase then decrease. If velocity increases then decreases, acceleration must go from positives to negatives. So you could say, therefore, v prime must equal 0. Similar to that. I like the mean value theorem and going with that. All right, last question. Did I make the adjustments to this guy? Yeah, this guy was a messy guy. This guy worked out. Make sure you know hundreds of B's. How quickly is the rate of change in B's changing? Cool. That way you don't have to worry about finding if it's increasing or decreasing. This all worked out well, and this we'll find out. I think I did this earlier. Oh, no, the last one doesn't work out well. Let me look at P of T really quickly and make sure it works out. Change it up. Yeah, that doesn't work. We want it to be positive from 0 to 8. That's good. So I just need to change this. I think if I change this to 18, doesn't work. 16, 17, 18, 20. That's not great. 14, 13, 12, 10, 9, 8, 7, 6, 5, 4, 3, 1. No. 0. Yeah, that works. Okay, so change it up. T cubed plus 9t squared. Get this out of my face. Plus 50. Okay. Great. Save. Print for future classes. Period 1. Yo, my bad. I'll send you an email. No, people get mad at me if I use that. What's it, 15? 20, 22, 20, 22? Call it 22, 23. 7, 6, 5, 35 to 40. Sorry, if I don't do this now, I'm never gonna do it. I'll save the PDF for a little bit. All right, so we're getting rid of the 12t, and then everything works out kind of nicely. All right, North Station versus South Station, both compared from 0 to 8. We have North Station had 50 people in it, and South Station had 50 people in it. South Station, you'll see why that makes sense. North Station kept track of entries and exits and calculated a rate of change, whose rate of change is decreasing, of people who are in the station. This E is a rate of change. This E is a people per hour. South Station was able to track the total amount of people in the station, modeled by P. South Station is a P. South Station is people. North Station is people per hour. Cool. One's a rate of change, one's not. Literally using P for position, which is great. Well, it makes sense that the amount of people in South Station at time 0 is 50. There it is. Cool. Use a trapezoidal Riemann sum to approximate the total number of people in the station at t equals 8. Well, again, if we accumulated E, you would get a change in a position. So I don't want to use P, but like this would be the total people at 8 minus the total people at 0. That's not what we want. We want the total people at 0 plus that accumulation. Don't forget initial positions. So total people at 0 is 50 plus this trapezoidal approximation. I have a half of 2, 50. I have a half of 2, another 50. I have a half of 2, 25. I have a half of 2 and negative 15. Yeah, great. So, boom. 50, 100, 125, 110, plus 50, 160. So there's approximately 160 people. Not who are in the station. Not entered. So that's another thing I should change. Shoot. In the station. Cool. Over or under? E's rate of change is decreasing. E must be concave down because E double prime must be negative. E prime is decreasing. E double prime must be negative. E's concave down. So if you look at the graph of E, it's increasing and decreasing, but it's concave down. That means the trapezoids will be under because E is concave down because its rate is decreasing. Approximate E prime of 1. Cool. E prime of 1. I would like you to do this. Is approximated with the average rate of change of E from 0 to 2, which is 10 over 2, which is 5. This would be people per hour squared. Interpret this. This means that the rate of change of people in the station is increasing. Five people per hour squared. Compare the total amount of people. I need to look at the total amount of people at time 8 and compare it. And I need to pause and go outside. All right, outside now. P is literally how many people are in the station at certain times. So P of 8 is negative 8 cubed plus 9 times 8 squared plus 50. I don't know what that amount is. I don't know the answer to this. This is not something I would do this with a calculator. But I don't want you to do it with a calculator, but this is the amount of people in the South Station, and then we approximated the total amount of people in North Station was 160. I think this guy is gonna win. Yeah, so let me just do it real quick. Oh, okay, yeah, I can just find P of 8. 114. That's perfect, actually. Why is that perfect? Because this is already under. I'm sorry that you have to do this work, but If this is already an under approximation and your other guy is underneath your under approximation, I mean, this guy's got to be a winner. So North Station wins. North Station wins. And more people. Is the people in South Station increasing or decreasing? Well, is the people increasing or decreasing? I need to look at the derivative being positive or negative. P prime is something I can find. P prime is negative 3t squared plus 18t plus 0. That's perfect. P prime of 1 equals 15. This is people per hour. So number of people is increasing 15 people per hour at t equals 1. It's the absolute number of people. Guys, look at this. You could take our derivative and set it equal to 0 and do a sign analysis. Pull out a 3t. Pull out negative 3t. I got t minus 6. This is why this works out so nicely, because we could factor this. So I got 0 and 6. 0 and 6. I mean, honestly, this works out phenomenally. If I plugged in 1, we'd get positives. If I plug in 7, I get negatives. P prime is positive. P is increasing, then decreasing. P of 6 must be the max, as P prime is greater than 0 from 0 to 6, and 6 to 8, it is negative. Okay, P of 6 is negative 6 cubed plus 9 times 6 squared. Plus 50. That's the max number of people. All right, really good question after making some adjustments, which I did. Good review. This is just extra problems. You have all of your homeworks, you have all of your quizzes, you have the extra practice classwork from day 2, day 3. If you don't have enough, ask me. I'll give you even more, okay? But this should be more than plenty. Let's do well on Wednesday and Thursday. Peace.